Mr. Cardoso.
Mr. Christian, how you been?
Good, welcome back. I hope today is a little bit more smoother than yesterday.
Me too. I hope it's going to be much easy. And well, we're testing a lot of streaming solutions, so hopefully this will be the last one that we test.
Yeah, let's see how this goes. So, okay, let's pretend. Yeah, let's start from the beginning again. So,
Yeah, let's do a
uh,
review. I brought my sweatshirt from PyTorch Developer Conference, so I hope that doesn't sound too
oh no, not welcome here. I'm kidding.
well.
Uh, okay, so as we were yesterday, we were exploring like a previous episode. I coded the learning rate function. So we checked the original code. There is a get learning rate function, which I kind of tried to reproduce line by line. It turns out that doing conditional statements like this is not that easy in JAX. I came up with a solution that was suboptimal, but it worked.
So just to get clear, so you were implementing the cosine warm up schedule for this, right?
Yeah, so
Perfect.
we had this warm up phase and then the cosine decay, but this is like programmed like this with, I guess, Python. What I was doing, what I did was use JAX switch statement, but I later found a better way. But I don't know, maybe for its own episode. So turns out, and I think David already knew this, but I didn't at the time, that there's already the schedule is exactly implemented in Optax. Um, it was good that I reproduced it because I could check it numerically. But yeah, I figured this was the exact function numerically.
You did stream? You did on the stream that you
No, I
that
did this
you
offline. So after I finished, like later at night, I was just kind of curious, like, okay, what's kind of the better way to do this? So I started scrolling through Optax code, like, hey, how do they do this? And they use one trick which simplifies stuff, but ultimately they code this already. So yeah, I just checked it numerically and used it. So yeah, the nice thing is that with the default parameters here, from like the variables we get, we can set each of the parameters for warm up, cosine decay, and it works good. So that was kind of I guess the initial thing I did offline for those who maybe saw the last episode. I just changed up the implementation, basically just deleted code, and that was nice. So the RL schedule simplifies to this, and I remember that I was about to modify the training loop. So just out of curiosity, I finished the training loop, which basically was just it wasn't hard. It was just changing like the like line by line, the small differences from the PyTorch world, we can take a look at what we have here. So yeah, the learning rate, we pass it directly to the schedule, to the optimizer, so you don't have to like update it yourself. The optimizer updates it on its own, so we don't have to do any of this.
Perfect.
So this was deleted. The weights of bias is log. It's exactly the same. We really don't change anything, so it's kind of good. Here for the checkpoints, it does change a bit because we're now using a Flax checkpointing system. So what changed? Okay, yeah, what changed here slightly was that the learning rate, we have to like in the other code it was iteratively defined.
Yes.
Here we have our learning rate function, so we have to use that. That's kind of the only thing. So we report the learning rate and some logic if it's kind of a constant. So yeah, that was that.
It's
Eh,
for the checkpoint, so Flax. Okay,
Okay,
checkpoint.
yeah. For the checkpoint, we're gonna use the checkpoints module from Flax, which
Mhm.
has the save checkpoint, so very similar. Uh, it it has like the main difference is that here we serialize the whole state. So in the PyTorch world, they serialize the model and the optimizer. Here, I mean, we could do something similar, but we can just serialize the whole state object that contains the parameters and the optimizer state, so it's the same. And we just fill in some like overhead. We have to use this. Well, Flax is starting to use this Orbax library.
Yeah, that I guess is by what we talked last time was very well documented. How custom to it.
So this is under development, but there is an example in the Flax documentation, and it tells you, hey, just do this, and well, you just create this checkpointer and pass it here, and it works. So transition was of this part was like very simple. The last thing that changed was that here the training loop is coded like inline here, whereas in the JAX world we created on a previous episode a training step, and we just call this. So this is kind of the training procedure, and the rest is just the same, except we delete some stuff related to, I don't know, some things for doing a data parallel, which on the JAX side we will eventually do differently, but we don't need this flag and thing. So yeah, it was deleted, and this is what we end up with.
So for today, what are the objectives of this of the JAX framework?
Yeah, I think the objective for today.
Mhm.
Uh, so there's something I wanted to do. So there's runs. Let me just show you runs. One thing I wanted to do is, so we're gonna train with Shakespeare, which is really small, and I noticed when I run it that it was starting to overfit really quickly. So what I wanted to do is change a couple of these options. So Python train. So let me just change, for example, warm up iterations to, I don't know, like 100, and then change the learning rate. Oops. By the way, if anyone is in the chat, I'd love to know if the music is too loud or not, because we hear I hear it at a different volume.
Just so everyone, I'm really looking at the chat. So if you have any questions or doubts, probably just to let you know, these parameters that Tristan is setting up are related to the optimizer.
Yeah, this is setting like a schedule. So I just wanted to put like a, I don't know, something simpler, just kind of to test, like whatever, like 2,000 steps. And then I guess yeah, max iters. Wonder why, if this is used. Okay, yeah, it's used.
Termination condition.
Yeah, I wonder why max iters isn't just the addition of the other two. Should technically be, but I don't know. Ah, no, because you can extend it. So yeah, you can tell it to run with the minimal learning rate for a while. So maybe max iters equals to, yeah, let's just put the sum like this. So this should train. We should even see. Okay, well, you can't see, but yeah.
Can we take a look at the 1dB? Because you're not showing in 1dB, right?
Yeah, I'm not showing 1dB. For now, let's just see it running. We'll print the values in the console, I think. Oh, I wonder if we need to change how often it evaluates. Yeah. We need to change. Let's just kill this. When it stops compiling. Yeah. Okay, yeah, a lot of configuration. Let's put, no, sorry, eval interval. Let's put it like something like
30, 50, 800.
Like something like 250. And then eval iteration, let's put it to something smaller, like I don't know, 15, something small. And log 1dB false, because we don't need it right now. So hopefully this, after it compiles and everything, we should see it training. And one of the things I wanted to add, but it's useful for the exercise, is finish the generator. So we currently only have training, but we can't produce samples because we haven't ported the generator, the generate method. So my idea was, okay, let's code the generate method. Okay, it's training.
So that's good. And it goes down. That's actually
it goes down. Machine AI solved.
I just wanted to throw that it's. Have you read this new document that Google Research put to like optimizing hyperparameters and these kind of ideas?
Like what? Sorry.
have you seen this document provided by Google Research that they put it in a GitHub?
Yeah. The tricks and tips. Yeah, I read parts of it. I want to give it like a full read, but it's
Yeah. It's funny because like things like that is that we're going to first before it's kind of finding this set of parameters. It's a complete engineer trick, especially
yeah,
for the parameters of the optimal.
yeah, no, for
Just
sure.
mhm. Perfect. So and this only runs on one CPU, right? Just to have one question.
S- Sorry?
It just runs on only one CPU, right?
Yeah, so right now is running on a single device. I forgot how many iterations we set. Every 250. Okay, once it reaches 250, it should evaluate, and it's running on a single device. Yeah. Let's wait a second. Evaluating. I just want to see the loss. The loss of the. Okay, the validation loss is not that bad. Okay, here we get some weird TPU allocation warnings, I guess. I don't know why they try to warn you. Large. Okay, it's allocating large. Yeah, I'm curious about this. Okay, so there was an additional optimization I went through because I was getting out of memory. And okay, no, I didn't do it. Very curious. I thought I did it. Yeah, the additional optimization I wanted to do, maybe I could do it now, is to donate.
Donate arcs.
Yeah, sometimes it's a little bit problematic, but
Just we have one question on the chat that I will respond. That it's is the weight and biases API for setting up the device? No, we're just using as a experiment log tracker. So no setting up device.
okay, yeah, the additional optimization we can do is to donate this state,
Mhm.
which I thought I'd done. This helps sometimes to avoid out of memories.
So could you while we get to the other iteration, could you explain a little bit more how the donate arguments works in JAX grid? So what it does do? I think we didn't talk about it, right?
Sure, no, I haven't talked about it. So the thing is that JAX is not like in PyTorch, where and in TensorFlow, where you have like stateful operations over your tensors in those frameworks. So what happens is that since it's functional, every time I input a state, when I output the state, oh no, wait, I did do it here. Okay, it's the same. No, actually, we don't want to do it here. Okay.
Because the state is it's important.
No, here you can donate it. In forward you can donate it, but in training, yes. So when you input the state here, and
Yes.
and this is JIT, and because of the transformations, this reference, let's call it by the Python, what is happening is different. So and the output arrays are also different. So you're suddenly holding like the original reference, which is held by the garbage collector. Even if you reassign it, the garbage collector takes a while to delete the reference. And you have the new reference. So two references are temporarily leaving, and you're kind of counting on the garbage collector to work quickly. But even that is not enough. Just the fact that it takes time. It's already a problem, so the solution on the JAX world is to donate, the buffers. So this will say like, hey, whatever buffers are contained in state, if I don't know how it does it. I guess it tries to either pattern match or just do it by type. Like if an output can reuse this memory, do it, and you tell it like which ones you can donate. So in this case, we donate this. So what happens is that once these arrays are input to the GDIP program, which in this case is this one, they will be invalidated. You cannot use them. If you try to use them, you get an error. Like they're just they don't point to any memory, or well, because this is more of a like a distributed setting. They no longer point to whatever handles the memory on the TPU. So yeah, that's how it works. Okay, yeah, I also added this decorator which just prints when the function is compiling, but it's not special.
That comes from, that's your implementation, or that's
Yeah, no, I just implemented it by myself because sometimes you want to know if a function is by accident recompiling. So for example, for like, you should only see compiling train step once. If you see it more than once, then something is wrong. So anyway, let's look at what we have here. Yeah, so the training loss is going down steadily, but the validation loss, if I remember, is kind of stuck. So it might be that this dataset is very small, like 5.1.
I think we ended also with 5.1,
5.7. So maybe we have too many parameters. I don't know. So yeah, and here it increased. So what I wanted to do is sample, just to get some sort of validation. So that's what we're going to do today. Okay, so sampling is implemented in the model. Here, and we in the generate function. So I guess we try to port this. I wonder what is the best approach. So let's pretend it's a method, but we have to get a couple of things. We have to get the params, like additionally. So I don't know, when we call it outside, we need the params, and here we need to call like apply instead of the call. But there is something even worse. This whole thing is in a for loop, and like we need to basically the optimal thing would be to create a scan. So I think that's what we're going to do. So I think we're going to create like a function. We're just going to copy over to like a function, generate And or maybe we can code a function here like inline, just so we get stuff via capture. Yeah, let's code the function inline, but we
We
will
are
need
going
to use scan. That is kind of the main difference. And I think we should also JIT what we're doing. But
But
I'm not.
a small question for me is actually,
Yeah.
so you have max new token, but there's should be a way that I get a stop token and I should stop, right? So with the scan, how you're going to break out of that, or that is not correct?
No. We could even use the new for loop. No, but I don't want to mess with for loop. Maybe that's an interesting episode. There's a for loop primitive that is supposed to be a little bit more friendlier than scan, but I haven't played with it, so I think let's leave it like this. I'm very tempted to change this
Inline.
so we have forward here, which knows how to apply stuff given a state and a batch. Do we have a batch here? No, we're sort of starting from IDX, which will be yes, this will be sort of our. Okay, now let's not use forward, but yeah, one thing we have to do is we have to somehow JIT what we're doing. Let's see if we don't get in trouble, but let's see, there are a couple of things. So self is a module and it's static. I think I'm gonna leave it like this, and then I'm gonna JIT in the main script. I think that would be better. So
Yeah.
okay, this for loop we have to change it for like a function. So def scan function and max new tokens. So
This is of type integer, I guess, and then
yeah, this is not what we want. We have to do things here differently. So okay, what do we want to do? We take a condition sequence of shape bt and complete the sequence max token times. So thing is, we will sort of have to add some padding, because in the torch world, let's see how they do it. Yeah, they concatenate stuff, and the tensor grows each step. That is okay for PyTorch, but
for we need to have boundaries.
in the JAX world, we need to sort of define it beforehand. So what we can do something like this, like I don't know, tokens equals, and we're going to do something like jmp dot like I don't know, zeros. zeros, and let's do something like BT equals, yeah. So what is going to be the shape? Yes, thank you.
Copilot.
So no, it's not gonna be this, it's going to be this. So we have batch, so we're batching, but we are going to have max tokens, and then we are going to replace the first n. So the first, such that we put the original one, so that could be something like, it's so smart. Yeah.
Copilot not JAX better than.
Yeah, this is good.
Yeah.
So this is JAX way of basically doing setting in place, but obviously there's no in place in JAX, so we do it in a syntax that looks a little bit similar, where we pick the range and then we pick the value, and it's almost like this, like if we wrote this t equals, yeah. So this is what we're doing, but in JAX way of doing it. And this has now the correct shape. So during the scan function,
good morning, sunshine.
I think we're gonna take like an index. I suspect we're gonna have an index, and we're gonna have x, which is going to be, let's just name it tokens, really. And let's see what is up. If the sequence context is growing too long, we must crop at block size. Okay, let's for now not do this.
Yeah.
Yeah, let's not do this for now. Here we're going to do like apply.
But then you need to state, right?
So we need params, but we have params, and here we have tokens. So okay, scan takes, we have to put this in a different order. We'll see how scan works, maybe as a refresher. But if I remember correctly, in scan you have the carry variable and then the input.
So the signature for that is F and F index S. So hold on. The function F requires.
So signature in Haskell's.
No. The first is a value of the loop carry, and the second is a slice of XX.
Token. If we do Haskell parlance, it's something like carry, and then A,
and then it gives carry and batch.
It's carry and then the output.
Yeah.
The output. So we're gonna be carrying the tokens. That's kind of what's gonna happen. And our input, it's just going to be the index, and our output is actually going to be none. We don't really have the output. We're carrying over the tokens. So this is what we're going to do, and this is going to be the index, and this is going to be the tokens if we just replace them. So
just to let you know that apparently JAX scan is compile the function, so pulling it on this will be unnecessary.
Yeah, that might be true.
That might.
Well, that is true, but then this part, the overhead, you can reduce it by
Yeah.
compiling the whole thing. But yeah, that is true. Also, you don't want to, because we're gonna call this, you don't want to create the JIT function again and again. I don't know if I know there's a cache, but I don't know how if there's going to be problems. Okay, we have the logits here. If we have apply tokens, all this is good. We get the logits. Let's see, block the logits at the final step by the desired temperature. Okay, they get the final state. Okay. Okay, no, this we cannot do because -1, we don't have -1. Like in PyTorch you can do -1 because you can grow, so you know that you always want the last one, but we want something like I. We want I. So either I or I -1. I think it's I.
I think it's I.
So we want the logit at the ith position.
Arrive at the temperature, yes.
This is kind of assuming, yeah, all the sequences are the same length. Yeah, this is good for a server, maybe. It's not that good of an but that's like an optimization. So okay, let's see. Let's port this part. JNP. Oh, JAX dot Flax top K. Let's see. Top K. There's a top K. Let's see what it takes.
The top key values and the reason along the
Operand and an int. I think that's right.
Yeah, makes sense, right?
Mean top K. Okay, no. Logit size -1. So size is shape, right? So this is basically just the number of tokens. So it's kind of the minimum. That's fine. So this should work. It should work. Let me just check something. My only concern is the axis. Is this doing it on the along the last axis? Okay, yeah. Okay, it's doing what we want.
But then technically shouldn't be only top K, not logit shape -1, because you assume it's in the last axis.
No, this is just a number of tokens, and it's taking the minimum. In case you pass top K by default is none. So
okay.
Actually, if it's none, it will be skipping this. So we're not even gonna see this. What it's going to do, so we need to replace this. Logit equals logit at set. So we need to use the other notation. Okay.
Oof, minus
Inf.
infinity. Ah,
So yeah, set them to minus infinity. And ooh, what is this? Return. Okay, it also returns a tuple like in Torch. I hope that it's the same.
that's good.
That this is correct. Ooh, why is this? Okay, this is a little bit sketchy. I don't know what is happening here. Is this like this?
For me, what I understand is setting all the other side of the logics that are not in the top K as minus infinity. I don't know why he needs to return that.
List minus one. List minus one. Oh, sorry, just
What?
okay. Yeah, sorry about that.
What?
I usually don't index with list. I wonder what this is. Is it the last? Is it all but the last or just the last or? Ah, I think this is like the last, but
Except the last one.
no, but keeping the dimension, something like that. So this seems like it's equivalent to this. I'm gonna put this because I understand this better. We're not gonna use this, so I'm gonna skip over this. So okay, yeah. So here we're calculating like a softmax.
The submat doesn't receive dimension.
Axis. Okay, yeah, props. Ah, we need to sample. Okay, yeah, this is where it starts to get interesting. So we'll need a key. We will need a key. So let's get a key here. Key on the params. We need a random key. So in JAX, we cannot just sample. We have to provide the random state, right? So here, let's create keys. We're gonna create a key for each step by doing like a split. And max new tokens to complete the sequence. Ah, okay, no, wait. This was good before. So let's create something like T what? Something like final T. It's already big T. T complete is yeah. So T complete. Yeah, this is a complete size. But we're gonna split. Okay, yeah, we're gonna split max new tokens. That is fine. And we need the indexes. So we need the I that I put there. So okay, yeah, exactly from T to T complete. Perfect. So what we're gonna do is that we're gonna put here inputs, and here we're gonna put I comma key equals the inputs, and these two should have the same length because they both have a length max new tokens. yeah, actually, just to express that, let's express it like this. And let's just remove this T complete. Let's get back to where we were. Max new tokens, yeah. Just so we know that the math works. So this thing is gonna have length max new tokens, and this thing as well. And when we do the scan, we're gonna scan over this, and then the key. So now that we actually have a key, we can use jax.random. Let's see what is the multi. Oh, what is categorical? No, Bernoulli. It's categorical. Yeah. Okay.
It's categorical.
Thank you, Copilot.
E logits, and yeah, it goes into the last axis.
Axis -1. Okay. So we sample from a categorical with a key. So the key has to be different for each input, which is why we created like a bunch initially. So that should work. And so the last thing they're doing here is that they're concatenating. We cannot concatenate. We have to update our tokens at the position I. So tokens equals okay, Copilot is very good. Let's refactor a little bit. Next token. Yeah, next token probs.
Next token, no, it's singular. Because that returns. What is the shape of that?
That should be. Wait, next token. So
the whole processor code shape equal to mp delete logits.shape and the axis.
I'm guessing it, since it's discrete, it removes the axis. So I think, yeah, this is what we want. But we can put the debugger here if we have doubts. So okay, we have this scan function. Now we need to scan actually. So okay, thank you, Copilot. So what does it take? This takes. Okay, we have a problem. First, we haven't returned the tokens. And oops, sorry. We're gonna return on here. We don't really have an output.
We called discussion like 10 minutes ago.
Yeah. So we scan this function. We have our input tokens. We get tokens, and then we get none. So we just put it like this, and then we return the tokens. This should be like our sampling procedure. This part is a little bit doubtful, but we will probably not use it. So what I want to do is during the evaluation phase, just generate some samples and see what we get. So here we have. So we evaluate the loss, and then let's create like a routine to sample. Def sample. So we have like our state, and for now, let's just keep it at the state. JAX.jit. Maybe we can put some other stuff here. But okay, we need like a key, so we're gonna just set it to 0. Yeah, let's just leave it static. We're not gonna split it even. No, okay. No, let's accept the key, sorry. So we're just gonna call the module, which I think we call module. So okay, key and tokens. So we're going to call a module dot, okay, what is it called here? It's called model, I think. So model dot generate, and so here we have the key. So okay, let's pass the key.
Params, state params.
State params. IDX is tokens. Let me just change this a bit. Let's just rename these tokens also. Tokens. Oops, didn't work. Tokens. Okay. Tokens. Max new tokens. We're missing this, so max new tokens, it's whatever, 10. 42. Okay. I wonder if there is a parameter here. Actually, I haven't looked if there is a. Oh, okay, there is sample.py. Okay. So there's a whole script for sampling.
Max new token 500.
But I want to do it. I want to do it in the same. Yeah, for simplicity. I mean, technically we could.
I just want to check. I mean, it looks like you run the models. TikTok can get this. Hold on.
Sorry.
I'm just looking at the parameter. I'm just looking at the configs of the sample. Okay. See.
Okay. So this script loads the model and then does inference. I think this is better. Maybe we can do this. But I want to do something simpler, which is, so they call generate here, and what I want to do a little bit differently is to do it in line, so we can send it to weights and biases. This is probably not ideal because
I think it'll take a while to get transform this one.
we might be using more memory, so I think people in practice have a separate machine for this kind of stuff. Like one is only training and the other one is generating samples. Because you try to max out the memory for the machine that is doing training. So that's why there is this sample.py. But maybe we can first do it like this and then actually do the other script. Yeah, we could do something like that. So first do it like this, and then maybe we can port sample.py maybe in the next episode or something like that. But I just want to see it running and then clean it up. So okay, we have this sample function here. The other one has max new tokens. We are just gonna set it to 42 randomly, and we're going to do it maybe here, like okay. The only thing, I'm not sure. We have to decode.
Decode and decode this.
We have to decode. The only problem is that we have to port this script, which includes loading. So we would have to implement loading, which is not that bad, but we would still have to do stuff. So I wonder if there's an easy way to.
My my contribution would be like, what if we just, I want to validate that we can actually generate and then we'll do afterwards.
Yeah, maybe let's just generate and see if we can port the output later. So yeah, actually this would be just straightforward like this, like sample. So an interesting question is, what do we sample from? So we have the validation dataset. Let me see. So we have the validation data. Okay, we have this get batch split. So I don't know, I'm thinking we can do something like this. We can do something like sample batch, and then here would be like val, batch. So we keep this one around, and then the tokens could be just this, something like this. So tokens equals sample. Okay, yes. So we set this key, and then here tokens equals. So yeah, 0. I don't think. Let's keep the batch dimension. And let's slice it. Ah, okay, no, this is 0, sorry. Yeah, this is 0. This is the 0th. Like the X, I guess. And then let's maybe have like the first 5. And then we generate apparently 42. I think 42 is too much. Let's generate like 20. No, that's for debugging 10. So yeah, maybe we can put like a breakpoint here. And run this. Oops. Sorry.
It's okay.
I'm just gonna put this thing that runs the debugger. Okay. Stuff should happen. Waiting for debugger. Add configuration Python. Remote attach. Okay. This is good. Okay. Let's see. Let's see what happens. Okay, it's compiling forward, so it's running this estimate loss. Okay, we get an error here.
The couple check for broadcasting 115 and 15 tokens at
Okay, 15. T is 5.
Max new tokens, how much is this? Token is 10.
No, this is clearly wrong.
Wrong.
Okay. We should rename this. It was called IDX. Input tokens. It should be something like input tokens. And then yeah, this is okay. Yeah. So these are the input tokens. These are the actual tokens. Yeah, this makes sense. Let's run it again. Okay, we have to run. We have to run this. So we should have changed the order. Okay, next time this is gonna run first.
Yeah. What is the shortcut that you do for moving lines between up and down automatically?
Something
Train.
like control up.
Okay.
Train, oh for sure. Train.
Yeah.
Train equals false. Okay.
Let's go back.
Should have wrapped. Should have wrapped this here, so I get compiling sample next time. I didn't actually save, but okay, we are here. We have tokens. We do have tokens. The sad thing
Yeah.
is that they don't mean anything.
Well, they are vectors. They are vectors. Yeah. But that's good. That's good. That was surprising.
Let's see. This keeps posting this. So just make sure tokens dot shape. So it's 15, which is what we wanted. We would need to use tick token to decode this. I guess. I imagine this was decoded with tick token.
Yeah, we saw on the sampling that was just given tick token and the. Can you open sample, please?
Yeah, let's open sample. Yeah, I don't know. Like putting the sample in a separate script and possibly a separate process is better, but what I would like to do is decode these tokens and then log them to 1db with an HTML object and have samples as text in the editor, in the console. That's what I want to do. So decode them, and then since they're a string, there is an HTML element in 1db, and you can put just the text, and that should work. But how long have we been streaming? I think we can leave for now, right?
Yeah, I think that's it because it's been an hour. Exactly an hour.
Okay, for next episode, or if I do it offline, that would be
No,
spoilers.
No, Mr. Christian, don't do that. This is cool too, so everyone can learn.
Yeah. Okay. So
Take it easy. Let us wait until the next stream.
so yeah. Yeah, we'll continue for the people who probably most people watch this offline. So yeah, let's try to not do a lot of so people can follow. If you have questions, yeah, just put a comment on the video, or I think most people come from Twitter, so you can just leave a comment on Twitter. And well, yeah, this is exciting. I wanna see.
That was fun. That was fun.
I wanna see some samples for next episode. Figure out if we are training on like if the model is just overfitting, and if it works. I mean, if the model learns the dataset correctly, we can pass to maybe train on the real open web dataset, which was kind of the initial idea, but the problem is that we're getting some like out of memory issues. So out of disk, we're running out of storage. So I think I already have like a separate machine, and we like the goal is to actually train on that larger dataset. But for next episode, yeah, let's just generate some samples, put them on weights and biases.
We'll continue on the Shakespeare. My goal here is also to keep you on the loop that feasible stuff.
Yeah. It's always better to train on a small data set, debug there, make sure that everything makes sense, and then actually just pass to the real stuff. But that would be a good way to debug. So yeah, Mr. David, thanks for joining.
No, that was really fun. Honestly, I I didn't recall that you need decode the tokens, and I thought that maybe we will be able to get samples by the end of the video, but that was a bit of reality for me.
Yeah, okay.
uh,
That's
it, I have one small question. I saw that there is a new. You retweeted a while ago about um, fold, fold L, fold left, fold for splitting keys.
oh yeah,
Does
yeah,
that
yeah.
does that anything help here on when you're trying to do that? I don't know if you mind to have like an example of this fold L
Uh,
approach.
so we could have technically used what you're saying.
Yeah.
Uh, Let me just show it. We could have kept I here
Mhm.
and then kept this key.
Okay.
This key here. And what we could have done is something like step key equals JAX dot random dot folding, and we would put key, the base key, folded by this index. So we would get a unique one per step, and then I guess here we could have just changed it like this. This would have been equivalent. The only, I mean, it's nice because we could have done that, and we can just, if you want, we could even test it. So it would have been just indexes. What did we name it? Ah, well, we comment the wrong one. So we could have had indexes, and the code would have been much simpler. Only slight problem is that usually if you can split once and reuse it, it's faster.
Okay.
So splitting inside the loop, it's not like ideal. And if we can split like ahead of time, that is most like recommended. But yeah, this would work. Splitting like this.
Can you run it just to make sure that it's?
Yeah, we can run it. I'm going to. Sorry. I'm gonna run it without debugging. Should not crash.
Famous last words.
Famous last words, but should not crash. Compiling sample, yeah, it worked. Thing is, do we want it like this? I like this because it is simpler, but I don't like it because it's slower. So, like pros and cons. Yeah, I don't know.
No, that made it simple. Thank you for taking the time to explain.
I will revert this, but yeah, that was kind of a conscious choice I made when I was coding this. This is a little bit more optimized in theory.
Well, honestly, this has been cool. Thank you. It's good to know that now in technical interviews I can ask someone to just port Nano GPT
Right.
JAX interview.
Yeah, no, that's a little bit crazy. Yeah, I mean, yeah, hope this was useful. I'll commit the code, and I guess we'll see maybe this week. Would be nice to finish it. not
That's
so
totally fine.
to finish it maybe this week. And actually, I want to start training on the big data set. So, yep. Okay, Mr.
Thank
David,
you,
thanks a lot.
Christian.
Thanks
All
for
right.
joining, everyone.